Hey guys, we're going to do the homework for 5-3. Okay, so here's some of the notes we took today. And here's our assignment. Okay, so let's take a look. It says question 11. Given the midpoints of a triangle, okay, so given, we're not doing 10, so I'm going to just kind of sketch a picture here. Given the midpoints of a triangle, which 2 points of concurrency can you locate? Okay, so if I'm given this, let's say this is point D, E, and F. So if I'm given points D, E, and F as midpoints, I can either trace it back to the opposite side, right? So I can find the centroid, right, using medians like we did today, or I can find the circumcenter using perpendicular bisectors, like I did the other day. Which points of concurrency can you locate if you only know angle bisectors? Okay, so we know angle bisectors make incenters, okay? Which 2 points of concurrency can you locate by drawing perpendicular segments? Okay. Perpendicular segments, things that are perpendicular lines, also like we found out altitudes, make orthocenters, and perpendicular bisectors make, we already said it, circumcenters. Okay, so that's a big question, but those are all the types of ways and how we can make those ways. All right. Question 14. Mathematical. Where is the centroid? Okay, so I'm going to cut this in half, cut this one in half, and cut that one in half. Okay, so I've cut those in half, and now I'm going to trace it back to the opposite side. So I'm going to trace it back to the opposite point, and it looks like it's right there. So where is the centroid? So I think actually I can find it just by tracing this line. I really only need one line. And notice the distance of this line is 4 units long. And we know that, based on our notes, that it makes 2/3. So if I kind of made this in 3s, I know the centroid is 2/3 of the way there. So I can say, well, what is 2/3 of, and of means multiply, what's 2/3 of 4? So I'm actually going to get a decimal here. So let's figure out what this is. 2 times 4 is 8. Divide by 3. Okay, so I get 2.6 repeating, or I guess if I rounded it, 2.7. So this coordinate would be 2.7. So that's actually where, that's the y value, 2.7. And my coordinate, my x value, appears to be 2. So 2.7. That is my centroid. So it says, locate midpoints of any two sides, find the equation of the two medians. I didn't really use the equation, and solve for it. How can you verify the coordinates were found? Okay, so in the book, they actually gave 4 steps, and I was able to kind of just use one of the medians to do it. It's because it happened to be perfectly vertical. Okay, so but these would be steps if it wasn't a perfectly vertical line. Okay, identify whether each segment is an altitude. Okay, so if I drop an egg, ooh, splat, CE is an altitude. Okay, and we have to drop it from a, so this is not an altitude because it was not dropped from one of the corners. I've got to drop it from one of the vertexes of this triangle. Okay. Now, I did my altitude. What segment is an angle bisector? So let's try an angle bisector. So it looks like this line. Cut this angle in 2 equal pieces. So BD is an angle bisector. Okay. What else? Do I see any more necklaces? No. So I don't see any more necklaces. Okay, median. Median is cut in the middle and trace back to the opposite side. So D, I don't know if this is the middle because I would need that evidence. So I can't just assume by look like. E also doesn't even look like the center. So E is not the midpoint. L here is the midpoint, but it doesn't look like we traced back to the opposite side. So that can't be a median. This one looks like our best candidate. J is in the middle of segment GH, and they did trace back to the opposite side. So I like FJ as my median. Perpendicular bisector. Okay, so let's take a look at a perpendicular bisector. That would be to cut in half at a 90-degree angle. That's exactly what I see there. So that is a perpendicular bisector. Nice. 16. What is the value of KL? Okay, KL. So this is cut in 3 equal pieces. You see that there? So KL was cut in 3 equal pieces. This would be 1 piece. This 15 is 2 pieces, right? So that means this has to be 7.5, which is 15 divided by 2. This has to be 7.5, and this has to be 7.5, okay? So what is the distance of KL, the whole thing? It is the short piece, PK, is 1 7.5. PL is 2 7.5s, which was 15. That was what was given. And KL, which is what they've asked for, is 3 7.5s. Okay, so what would that be? $22.5. Final answer. Okay, now it says, this one's like example 4. State whether the orthocenter of each triangle is inside, outside, or on. Okay, so our notes say this is a right triangle, so it's going to land on the triangle at the 90-degree angle, right? Since it is a right triangle. This one looks acute, so I can kind of see like orthocenter, just drop an egg, boo, drop an egg, drop an egg. I think the orthocenter is right there, so since this is acute, it landed inside the triangle. This one's also looking acute. These would be the orthocenters. And so this one is also acute triangle, therefore it landed inside the triangle. And this one's obtuse, so this one's going to be landing outside. So we noticed this one would be the first one, this one would be the second one. This one would be the third one. And so if we extend these out, I'd end up with my orthocenter outside the triangle. Why? Because this is an obtuse triangle. Okay. 19. Find the example 5. Okay, so this is going to take some graphing. And graphing. Okay, so 19. All right, so I'm going to come back to 19. All right. 20. A large triangle-shaped table is supported by a single pole at the center of gravity. So we know it has to be the centroid, the center of gravity. So we find the middle, trace it back, right? Find the middle, trace it back. It's right about there, which is right where it looks like it's balancing. How far is vertex C from this center of gravity? Well, we know that this is kind of a cool question. We know that this is 8, and we know this is an isosceles triangle, 5 and 5. So we actually know these angles are equal. And we also know that's 4 and 4. So I actually know this is 3 using Pythagorean theorem. That's a really popular triangle. So if I don't know that length, I can call it x or a, right? And a squared, and this would be b, 4. Would equal 5, c squared. So doing a little algebra here, we notice we get 9. So I've seen this triangle before. That would be 3. So we know our centroid is going to cut this in 3 equal pieces. 1, 2, 3. And so it's wanting to know how far is C to this vertex, and it looks like 2 equal pieces. So if the whole thing is 3, then it's 1, 2 feet away. 2 feet away. This has to be 2 because this is 1 and the whole thing is 3. Neat question. Okay, last 2 and then we'll go back to the tricky ones. So select the true statement about A, B, C. What can we say? Segment AD is an altitude. AD is not an altitude because an altitude is like dropping an egg. This would be the altitude. So that's not what we have. So I'm not going to pick that one. Segment BE is the median. So BE, the median is find the middle and trace back to the opposite side. So it doesn't look like BE is the median. So that's not going to work. Point X is the orthocenter. So the orthocenter is created from the altitudes, right? So we have to figure out, are the altitudes intersecting here? It does, no. Point X looks like the centroid. So we're going to pick point X is our centroid because it appears to be the intersection of my medians. These are my medians. Point F is in the middle because of these 2 tick marks. Point D is in the middle and it traces back to the opposite side because it's the intersection of medians. Okay, and that one's not right. 24, a triangle has vertices of 3. Oh, wait, they're going to give me bigger numbers. Okay, 1, 2, 3, 1, 2, 3, 4. Okay, I'm going to call that A. 9, 17, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, I'm going to call right? And I'm going to call, sorry, somebody tried to call in. Sometimes that ends my call. And then I'm going to call this C, 8, 16. So 8, 16. So 1, 2, 4, 6, 8, 10, 12, 14, 16. This is a funky looking triangle, guys. It is really obtuse. So where would the centroid be? Oh, wait. You know what? I see I messed something up. It has vertices of A and B, but the centroid is there. Okay, so that's not my other side. That's my centroid. Oh, I'm glad I caught that. Okay. So my centroid here is at 8, 16. So, what are the coordinates of the third vertex? This is a thinker. So let's think back on our picture here. It's, if we have a centroid, it's from the center, from this thing, if I trace to there, if I trace to any point, it's 2 equal lengths away. So I should be able to trace to the point. So I can trace to the point from my centroid and trace to the point from my centroid, but that's not my triangle there. And then I have 1 left to go before I actually end up getting to my side. So 2 equal pieces and 1 left to go to get to that side. This is 2 equal pieces and 1 equal piece left to go to get to this other side. This is a whacked question. I think I figured it out. So I'm out here. That's my centroid. Now I don't really like how skinny this triangle is, but this is my other point. I'll call it O for other point. So where did I go? It looks like I practically went straight up from B. So where is B? At 9. Yeah, maybe over just a little bit. So I like this 10 coordinate. And then I went up some more. So that's not going to work. Ten, 7. Here, let me take this back here. 3, 4, 9, 17, 8, 16. Okay. Well, I can actually graph this and see how it goes. So this is 9, 10, 4. So would my centroid be over there? Well, no, that's outside my triangle. Would my centroid be over there if I was 10, 7? 1, 2, 3, 4, 5, 6, 7. Well, no. Centroid would not be over there. Let's try 12, 14. So 9, 10, 11, 12, 13, 14. Or excuse me, 9, 10, 11, 12, 14. So if this is 12, 14, here's my triangle. My centroid has to be inside, so I have to pick this one because the only one, so let's go ahead and do that, 12, 27, so it's way over here. Yeah, that's the only one I can figure out that that would be my centroid. Interesting. I don't know, something's weird with that. Maybe I'm missing something or I've got my coordinates. Okay, so let's go back to these graphing questions and let's see if I can do a little bit better job at this. Okay, so let's find the orthocenter of 0, 0. So I'm going to call that A, B, 8, 4, and C, 4, 22. 1, 2, 3, 4, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 19, 20, 21, 22. 4, 22. Okay. Now I look at that and I say, is that a right triangle? And I'm just not very good at graphing it. So I can figure out if it is a right triangle because it should have the slope of an opposite reciprocal. So if I look at this slope, it looks like I went up 4, right? I went from 0 to 4. So the slope is rise 4 over run, and I ran 8. So my slope was 1/2. So the perpendicular slope would be -1. Let's see if this slope is in fact -1. So if I go from slope, right, is the change in y over the change in x, right? So 22 minus 4 and 4 minus 8. So I get 18 over a -4, so not quite. So that is not, and so maybe my drawing is pretty accurate. So it looks like I'm going to get a coordinate. It looks like that's obtuse, so I'm going to get a coordinate that falls outside. So if I extend this line, this would be my first altitude. I see my line here. This would be my other altitude, so I can kind of extend that. It looks like right about here is where my altitudes are going to meet. Let me see my last one here. Yeah, okay. So if I extend this looks about right, and yep, that would extend there. Okay, so here's where I'm looking at my orthocenter, and it looks like I went out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So about, my orthocenter is about 14 up 2. That would be my guess. Out 14, up 2. So if it's multiple choice, I'm picking the coordinate close to that. All right, now let's do B and we'll be done for the day. I'm just going to erase this just so I'll have a little bit more room. Okay, so we have the coordinate 3, 1, right? 1, 2, 3, 1. So I'll call that A. And I have the coordinate 10, 8. So 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I'm going to call that B. And then I'll call that C. So I went out 1, 2, 3, 4, 5. And then up 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 513 is C. Okay, so here's my triangle. Let's find our orthocenter. That looks like it's a right angle. If it is a right angle, then our orthocenter is going to be at the right angle, which would be the coordinate of B. Okay, so let's just check our slopes to see if it is. So my first slope, right, change of y, so 8 minus 1, change of x, 10 minus 3. So I get 7 over 7. So the slope is 1. So the perpendicular slope would be negative reciprocal, right? So I get -1. So let's try that out. What's my slope? So this has a slope of 1. Now I'm trying to figure out, does this have a slope, a perpendicular slope of -1? Okay, so the slope of my other line, C, this one was AB, and this one is CB. We change in y, so 13 minus 8 over the change in x, 5 minus 10. So we get 7 over -5. Not quite, right? That's a decimal. Yeah, -1.4. So these are not perpendicular, so no, my orthocenter is not there. Okay, so this is not coming down at 1. It looks like it's coming down a little steeper than 1. But this is going up at a slope of 1. Okay. So looking for our orthocenter, we drop an egg, and we know this is not 90. All right, we drop our egg. This, drop a 90. And this, drop a 90. So it looks like maybe it's just outside there, okay? So I'm going to guess that my orthocenter is somewhere about, if B is at 8,4, I'm going to guess it's something like maybe 9,4, a little bit further out. And if it was multiple choice, I'm going to guess a coordinate somewhere close to that, all right? Now, we will go over algebra to find the exact coordinate, but at this point, we're just approximating using graphing. Thanks for joining us, guys.